Thank you for joining us. In this session, we'll go over the use of the Masonry Column program in the ENERCALC Structural Engineering Library. We have our project open, so we will add a Masonry Column design to the project. We see our typical column design screen. Again, you're able to switch between any material while you're designing the column, and all the loads and slenderness information and load combinations carry over. We'll leave for this session the top pinned and bottom pinned condition. A very important thing to show you is the analysis method. In steel and wood columns, we say it's ASD or LRFD design. In masonry, we use the terms a little more appropriate to concrete and masonry design of working stress and strength design. As you will recall in some of our older software and in other programs, when you're designing a column based on working stress design, to determine the final allowable stress ratio, you take the ratio of actual to allowable axial stress plus actual to allowable bending stress, and that's your stress ratio. But with the advent of strength design and some other methods years ago, the more proper way to do this type of analysis now to get a capacity is to create an interaction diagram for the particular column. And so this program, of course, you always use an interaction diagram in strength design, but we also create an interaction diagram for working stress design. So if you run any old columns that are designed with working stress in this program, you will typically see that the columns have a higher capacity, both moment and bending, because we do a more accurate analysis using design methods to create an interaction diagram. So we'll use strength design for this session. We'll go to the masonry tab, which allows you to specify the properties and the size of the column. So on the left here we see the masonry properties. This is nothing new. We can just have the typical masonry and reinforcing properties, the density of the masonry, and the tie bar sizes. Over on the right hand side, we've tried to create a very easy way to enable you to specify your column size. We have two different ways of specifying column size: nominal and exact. Of course, exact, you basically just type in the exterior dimensions of your column. Nominal, we have a very convenient way of selecting typical sizes for masonry modules that you can select, and it'll actually show the exact dimensions down here. That's the column size. You select your bar size, your longitudinal bar size, and the number of bars in the column with these drop boxes here. The cover over ties value is important to know that you realize that this is actually the cover over the ties. It's the measurement from the outside face of the column to where the edge of the inner tie bar is. And then from that dimension you will add the tie bar diameter. In this example it's 3/8 of an inch, and then 1/2 the diameter of the longitudinal bar, in this case it's a number 7 bar. So this value plus that diameter plus half this diameter will give you the location of your longitudinal bar that the program will use in all of its calculations for column capacity. Moving on to loads, this is not a biaxial program. The masonry column program only allows uniaxial bending, and that uniaxial bending creates tension and compression on the depth dimension. It's this dimension along the x-axis of the member. So let's add a load here. Just call it roof beam. Let's give it a 3-kip dead load and a 4-kip live load. Let's give it an eccentricity of 6 inches. we'll leave it at the top of the column. We will have the program include the self-weight of the masonry column. And then let's also put in a lateral load. Perhaps this column is collecting wind loads from an adjacent wall. So we'll just put in a full uniform lateral load. Let's make it a wind load of maybe 100 pounds a foot. We can look at our loading here. There we have our axial load, our lateral load, our column cross section. We also want to give this column some slenderness. XX column slenderness. Let's see, how high was this column? 10 feet? Okay. Let's just use 10 feet about both axes. That'll get a reduction going. Actually, it looks like we aren't really having much of an effect. The stress ratio is so low. So why don't we kick this column up to 25 feet? And we'll use a 25 feet unbraced length for each direction here. And we'll make this column a little bit smaller so we can get the stretch ratio up. Everything looks good for a 14 by 14 block size for axial loads plus bending. Let's take a look at the design combinations. Because we've entered a wind load, we have quite a few combinations that the program has run. So for each combination, here's our final stress ratio for bending. Actually, that's bending plus axial. Axial load values and our moment values. These results here give you the stress results for each load combination, the maximum stress ratio at each location along the column due to the applied loads, and the applied and allowable axial load, applied and allowable moment. And then we have some deflection calculations as well. Moving on, this is our actual interaction surface. We'll see it in a diagram down here. But for each increment of axial load on the column, here is our allowable moment, and then it's giving you a neutral axis location. These values are used to build this interaction diagram for the column. And of course we have end reactions on the column over here. These reactions are from lateral loads. And of course we have our standard shear moment and deflection diagrams for all the different load cases on the column. You can see here this is the effect of the eccentric axial load, and here we have our bending from the applied lateral load. I think that gives a good rundown. The real important part of this program is making sure to specify your column cross section correctly and apply your loads, whether moment or eccentric axial load, and review the results. It also gives you some reinforcing check area checks, dimensional checks, column tie checks, and of course, as you can see, we have the ACI 530 references here for your use as well. That sums it up. If you have any more questions about this or any other program, please be sure to send an email to support@enercalc.com. We're here to help you during the day or after hours and weekends. We get your email on our Blackberries. Thanks for joining us.